Now, before we get into the mystery of the Carolina Bays, I did want to take some time out to review what the scientific method is. And, this is something that as a science educator, that's probably the most important part of any science. And so any good science teacher should spend the first part of any course they teach or anything like that by just doing a quick review of the scientific method. And something that I like to do whenever I'm going over this with my students is to remind all of them that they're all scientists. They all go through these steps of the scientific method, in their daily lives. You don't have to put on a lab coat and shake up beakers and things like that to be a scientist. All you have to do is go through those steps right over there of the scientific method. And if you can do that successfully, you're a scientist. Now, in my classroom, I usually go through a couple different examples. They're usually kind of goofy, just to get the kids laughing and things like that. But again, we all do this anytime you've ever had to solve a problem. And so just a good, quick, easy example is just trying to decide what you're going to eat for breakfast. You wake up, you are hungry, you have a problem. Well, that's where we start, right? You state your problem in the scientific method. Now, once you have stated your problem, the best thing to do next is to research that problem. What have people done in the past to try to solve that problem? Now, again, in my case, I woke up, I was hungry. Well, what do I have to eat for breakfast at the house? Is there a place on the way to work that I can stop and grab a bite to eat? Should I wait until I get to the school and eat some cafeteria food? Whatever. I'm going to go through that running list in my head of what are my options to help solve that problem. Now, once you've done your basic research, you're going to pick one of those things that you researched and try to find a possible solution to your problem. And that's what a hypothesis is. It's not just an educated guess. I tell my students, that's a good fourth grader definition of what a hypothesis is. But you do have a problem, and we are trying to solve that problem. And so whatever you decide, whatever you think is going to be the best solution, that's your hypothesis. Now, the only thing that makes a hypothesis a good hypothesis is that you are able to test that hypothesis. And we do that through experimentation. Now, in my case, I went through a list of what I had to eat at home, and the only thing I came up with was an old stale box of shredded wheat, the big bricks that don't even have like the sugar coating or anything like that. It's just a big brick of wheat. Now, is that a good hypothesis? Well, actually, yes, because I could test it. And I would test it through an experimentation. In this case, I would eat that shredded wheat. I didn't even have any milk, so I kind of put some water in there to soften everything up, and then choked that stuff down and went on to work, went on to school. And again, I am now testing that hypothesis. All right, now for the next step, even though I'm probably not going to break out a notepad and start analyzing my data and things like that, or going through and taking notes on how I'm feeling throughout the day, I am going to be collecting and analyzing my data. And it's just going to be, how am I feeling at around 10 o'clock in the morning, as all that brick of fiber starts settling into my stomach, and got some bubble guts going on or whatever, and it's time to go. I'm definitely collecting and analyzing my data on whether or not my hypothesis was valid or not. And usually by around 11 o'clock, lunch is coming around, and I'm starving. I've already gone to the bathroom 3 times, and I'm now able to draw a conclusion on whether or not my hypothesis was accurate or not. And so, in this case, my hypothesis was found not to be a very good one, right? It was tested, it was testable, and I tested it, but at the end, my conclusion, my hypothesis is invalid. And for a lot of times my students think that that's it. We've reached the end of the scientific method, game over. And really that's not the case. For good science, if I get to the end of the scientific method and I find that my hypothesis is not valid, then I need to go back and form a new hypothesis and test that one, right? And we'd go through the whole step all over again. Now, if I do find that my hypothesis is valid, it's also not over. If you find out that whatever your hypothesis was ended up being true, well, then you have to test it, and you have to test it over and over again, and you need to have other people test it for you and things like that. And so these are all really important parts of the scientific method. And tomorrow I'm not going to eat shredded wheat. I might go to Hardee's or something like that and pick up a biscuit, or I might make an omelet or something. But that's forming new hypotheses, and then I would go through and testing them the same way. So. And again, we do this all the time for every decision you've ever made. Like I tell my students, if you're going to go out on a date, or if you are deciding whether or not to go to work after school or play video games, these are all things that we do to go through all of these steps. And because of that makes all of us scientists. Now, when we come back for the next video, we are going to use that. We're going to use those steps of the scientific method and apply them to the real true mystery of the Carolina Bays. Even today, we still don't know exactly what caused these things. And so we're going to look at that. We're going to look at a couple different hypotheses that have popped up throughout the years, some that have gained a little more attention than others. And we are going to kind of keep coming back to the scientific method to see, is good science being done or not, when it comes to these Carolina Bays. So stick around. We'll get to the meat of this thing next.